Good morning all of you. Have a nice day for all. On our previous class, we have been completed one chapter, which is the properties of quadrilaterals. And on that chapter, we discussed about different types of quadrilaterals and also some calculations, some problems related with those quadrilaterals. Okay. There is one more chapter that is remaining related with the quadrilaterals, and it is construction of quadrilaterals, and that topic we would discuss it later. Okay, and on our next week you would be having an exam based upon the previous chapter, properties of quadrilaterals. So what do you want to do is you need to prepare that chapter very well and attend that exam. Okay, all of you need to score good marks also. So that's all about the things we discussed previous days. Okay, and today it is the linear equations. Your third chapter we are going to discuss. Okay, let's have an idea about what is a linear equation actually. Okay, so one can say that a linear equation is a special type of, algebraic equations. Linear equations are special type of algebraic equations. So, what speciality would be for a linear equation? Does anybody know? Okay, just leave that speciality. Before knowing that speciality, we can have an idea about what is an algebraic equation. So, does anybody have an idea about what is an algebraic equation? No. Okay, leave that. Again, leave that. Let's have an idea about what is meant by an equation. Okay. I hope all of you have this idea. An idea of an equation. An equation is mathematical sentences that are written by using equal signs. So this is an equal sign, and the peculiarity of an equal sign is that for an equal sign there are two sides. One is a left hand side and the other is a right hand side. And an equation always says that the left hand side that would be equal to the right hand side, which means the all things or the complete value of the left hand side that must be equal to the complete value of the right hand side. That is actually referred as an equation. So in an equation, let's take an example for an equation. 2 plus 3, you know that would be equal to 5. So 2 plus 3 equals 5 represents an equation. Okay, in which the term 2 plus 3 is the LHS. Here LHS would be 2 plus 3. And what is the RHS? RHS is simply the number 5 itself. Okay, and you know that this value LHS 2 plus 3 is 5. So LHS and RHS are equal. That's why they are written by using an equal sign, and we call it as an equation. Okay, so an idea about an equation is clear now. Now let's discuss about an algebraic equation. An algebraic equation simply means the equations in which certain alphabets also would be there. Okay, here in this equation you can see only numbers. Okay, and in an algebraic equation there would be numbers as well as alphabets. numbers and both numbers and alphabets also you can see in an algebraic equation. Okay, so let's take some examples for algebraic equation. Here I am taking an example, x plus 3 equal to 5. This is an algebraic equation, and here you can see the numbers 3 and 5, and also there is a alphabet. Okay, and the alphabet here is x, and the alphabets used in an algebraic equation, they are called variables. They are called variables. Okay, and here the variable is x. Okay, now I am going to write another equation, x square plus 3x equals 75. This is another equation. Here also you can see the same variable, which is the alphabet used here. It is x, and that x is called the variable in this equation. So here also the variable is x, the alphabet used. Okay, but you can see some other things here, some additional things compared to this equation, which is that you cannot, it is not only the x or not only the variable, there is power of x also. Here is the second power of x, which means x square. Okay, square of x. We can have the cube of x also in an algebraic equation, or any power of x can be used in an algebraic equation. Okay, so in the second equation there are powers of x. Actually x here are variables, so powers of variables are also present here. Clear? Here also we can consider, actually here also we can consider a power for x. Actually the power for x here is 1. Okay, here on this equation x square plus 3x equal to 75, here the power is 2 and here the power is 1. Usually the power 1 we do not represent it. If we represent simply x, which means x to the power 1. Okay, but x to the power 2 can be represented like this. X on the top, its power 2 can be represented. Okay, so in general an algebraic equation is an equation in which there would be variables which are represented by different alphabets, and they are related by an equal sign. Such an equation, the mathematical equation, is called algebraic equations. Okay, so the importance of an algebraic equation is that in algebraic equation there would be variables as well as different powers of variables, like square, cube, fourth power, fifth power, or can be any power. Okay, such equations are called algebraic equations. So now we are clear about an equation and about an algebraic equation. So now let's go to special types of algebraic equations. Some special types we are going to discuss. Okay, so here I am going to write different algebraic equations. A plus 2 is equal to 10. 3x plus 5 is equal to 11. X cube plus 3x square is equal to x. X plus 5 is equal to 3x. So here there are different algebraic equations, and now I am going to select some of these equations which has got some specialities, and I'm going to tick those special equations. This one and this one and the last one. So 3 equations are selected, and I'm going to say some speciality is there for such 3 equations. And what is that speciality? In all these 3 equations selected, you can see that the power, which is the variable in this equation, it is A. And you can see that the highest power of that variable is 1. On this equation, there is only one term that contains variable, and the power of that term is 1. Okay. Now what about the second equation? 3x plus 5 equals 11. Here also the variable containing term is this 3x. And on that, the power of x is again 1. Okay. The power of x is 1. That's why it is not represented there. Okay. Now look at the third equation. On the third equation, the variable is x. But you can see that there are different powers of variable or different powers of x. What is the power of x here? Since there is no numbers, it represents first power or 1. Okay. Here you can see that the power is 2. And here you can see that the power is 3. So, on our third equation, which is the highest power of x, there are powers of 1, 2 and 3. Out of that, the highest power is 3. Okay. In the above 2 equations, the highest power was 1. And also, on our fourth equation also, you can see that here the power of x is 1. Here also the power of x is 1. So, on the fourth equation also, the highest power of x is again 1. Okay. So, that is what is the speciality of the first, second and the fourth equations. In all those equations, the highest power of the variable is, or the highest power of the alphabet used is 1. Okay. Such equations are called linear equations. Such equations are called linear equation. So the speciality of a linear equation is that the power of the variable or the power of the alphabet would be 1. The largest power must be 1. If it contains any other higher powers, then it will not be a linear equation. So I hope you clear about what is a linear equation. A linear equation is an algebraic equation in which the speciality is that the power of the variable, the largest power of the variable would be 1. Clear? I hope you clear about what is a linear equation. So now let's go to the features of a linear equation. Okay. Now we are going to discuss about solution or root of a linear equation. So I'm just considering a linear equation x plus 3 equal to 7. Confirm that it is a linear equation. Yes, it is. Why? Because here the variable or the alphabet is x and the power of x is 1. The largest power of x in this equation is 1. So definitely it is a linear equation. And on this linear equation, the x can have different values. You can put different values for x. And you are going to check whether this equation would be true or not. Suppose on the first case, I am putting x as 1. Then what would be LHS? On LHS, you can write 1 instead of x, so that it would be 1 plus 3. And on RHS it would be 7. And what would be 1 plus 3? 1 plus 3, you know, it is 4. And on RHS still it is 7. And you know that 4 does not equals, or 4 not equals 7. Okay. So we cannot consider the value of x as 1 for this equation. If we consider the value of x as 1, then this equation will not be true. Okay. Now let the value of x is 2. Then what happens? You need to put 2 here, so that it would be 2 plus 3 on the left hand side. Okay. And on the right hand side it would be 7. And again, on simplifying the left hand side, it would be 2 plus 3, which would be 5. Right hand side still it is 7. No change. And again you know that 5 not equals 7. So shall we apply the value x equal to 2 in this equation? If we substitute x as 2, then this equation will not be true. Okay. Then tell me which value you must have to put for x so that this equation become true. Simply looking at this equation, you can easily say that the value of x must be 4. The value of x must be 4. So that 4 plus 3 would become the LHS. Clear? What is the answer? 4 plus 3, it would be 7. And on right also it is 7. So on that case only the equation would be true. Okay. So what you can confirm from this is that only a particular value of x for which the equation would be true. A linear equation would be true. Only a particular value, only a unique value, only a single value of the variable. Okay. And that value is called the solution of this equation. Or otherwise it is called the root of this equation. So tell me, how many solutions are there for a linear equation? For a linear equation, there would be a unique solution, or there would be only one solution, or there would be exactly a single solution. Okay. And the peculiarity is that the value of x for which the equation would become true is called the solution or root of a linear equation. The value of x for which the equation become true, an algebraic equation, a linear equation become true, is called the solution or root of a linear equation. And there would be only a single solution for a linear equation. I hope you clear about what is mean by solution of a linear equation. Listen here. Now we are going to discuss about solving linear equations. Solving linear equation means actually it is a process. Okay. And the aim of our process is finding the solution of a linear equation. Suppose you would be given a linear equation. You need to find the solution or roots of that equation. For that, you need to follow some process or some steps. Okay, some rules. And that process is called solving linear equation. On our previous example, x plus 3 equal to 7, it was easy to find the root or to find the solution of this equation. But the case will not be easy, if our linear equation is a complex one or a complicated one. Okay. When our linear equation is a complicated or complex one, then we need to follow some steps. We need to follow some rules to find the solution of that linear equation. Okay. And that process is called solving a linear equation. And usually there are two processes or there are two methods by which we can solve a linear equation and find the value of alphabet. Okay. And those methods are, one is the solving a linear equation using inverse operation for elimination. Using inverse operation for elimination. And the other method, which is the simplest and easiest one, and it is transposition method. It is called the transposition method. So let's discuss which are the things to be cared of on both the methods and how do we can find the solution of a linear equation by using both the methods. Okay. For that, now we are going to consider a much more complicated linear equation. And we apply the rules for each method and find the solution of that equation. Okay. Now, on the first method, the rules is that when we add some number to the LHS, then it must be added to the RHS also. When we subtract some numbers onto the left hand side LHS, then it must be done on the RHS also. The third rule is that when we multiply something onto the LHS, we need to multiply the same thing on the RHS also. The same number is to be multiplied on the RHS also. And similarly for division also, if we are dividing some number onto the LHS, the same must be divided, the same number must be divided onto the RHS also. So these are the rules that has to be followed on the method inverse operation for elimination. Okay, so you would be given an equation. You can do operations like addition, subtraction, multiplication and division. All these four operations can be carried out on that particular equation. But the rule that has to be followed is whatever you do on the LHS, the same thing must be done on the RHS also. Okay. Then only your answer would be correct. Your solution would be correct. So this is the method of using inverse operation for elimination. Now on transposition method, actually we are not doing any mathematical operations. Instead of that, from the given equation itself, you are transpositioning. Transpositioning means changing the position. Okay, you are altering the position. And how you can alter the position on an equation? On an equation there are two positions, which is left hand side and right hand side. Okay, so you can bring some operations from the left hand side to the right hand side, or you can bring some operations from the right hand side to the left hand side. Okay, and the rule is that when you are transposing an addition or a subtraction operation, then it would be reversed. Then it would be reversed. So when we are transposing an addition operation, then it would become subtraction. When you are transposing a subtraction, then it would become addition. So addition and subtraction operations are reversed. Just like that, multiplication and division operations also get reversed in the case of a transposition method. So a multiplication operation on the LHS, when we carry that operation onto the RHS, then it would be reversed. Reversed means multiplication operation would become division operation on the other side. Okay. Just like that, division operation would become multiplication operation on the other side. When we transposition a particular operation, it would be reversed. Multiplication would become division. Division would become multiplication. Addition would become subtraction. Subtraction would become addition. Okay, so that's all about the rules that has to be followed in transposition method. I don't know whether you are clear about all these things, but I am sure while taking an example and discussing, you would be easy to understood this. Okay, so let's take an example of a linear equation and solve both these equations. Equations using the two methods. Okay, look at here. Here I have a linear equation 3x plus 4 equals 13. It is a linear equation. Okay. Now I want to solve this linear equation. Solve this linear equation means you should have to find the value of x for which this equation comes to be true. Okay. Suppose the solution, let's assume that the solution of an equation is 5. This equation is a solution or root of this equation is 5. Then how can you express it in mathematics? It means that the value of x is 5. How can you express it in mathematics? You can say it like x equals 5. Clear? X equals 5 means value of x is 5. Actually, our aim is we just want to change this equation, and finally we have to reach something like x equals a number. Okay, and that would be the solution of this equation. And here on our first method, what we are doing is we can have you can see that there are different operations here. There would be addition, there would be subtractions, or different kinds of operations would be on our given linear equation. We need to cancel each of them, every of them, and finally we need to isolate our number x only. Okay, then only we can find the solution. Okay, so what we want to do is we need to cancel or we need to eliminate all other things except the number x, the letter x. Okay, for that, on this first method we follow the inverse operation. Inverse operation means an addition can be cancelled by a subtraction operation. A multiplication can be cancelled by a division operation. Clear? That is what is meant by inverse operation. So, first of all, on this equation, to eliminate this plus 4 means here 4 is added. Okay. So, in order to eliminate this plus 4, we need to subtract 4. Okay, so that this 4 would be eliminated. But the rule is that whenever we subtract 4 on the LHS, we need to subtract 4 on the RHS also. Same operation and same number. Okay. So on the first step, I am going to eliminate this 4. For that, I need to subtract 4 from the LHS. It is LHS 3x plus 4. Then I am doing minus 4. Okay. And the same thing has to be done on the RHS also. First of all, we can write here there is 13 on the RHS. Now the extra operation is subtracting 4. So now there would not be any problem for this equation, because this equation would be balanced. Because whatever we done on the LHS, the same thing is done on the RHS also. So the equation would be balanced. Okay. Now on the next step, you can see that this plus 4 and minus 4 cancels. Okay. So that here there would be only 3x. You can see that this plus 4 is eliminated now. How it is eliminated? By inverse operation. We can do the inverse operation and cancel some terms. Okay. So this plus 4 is eliminated. So now on the LHS there would be only 3x. Then I am putting the equal sign. And on right hand side, you can subtract 4 from 13. 13 minus 4, what is the answer? It would be 9. Okay. Now, what is mean by 3x? 3x actually means 3 into x. Okay. And on the right hand side, it is 9. Now, again we need to eliminate this 3. Then only we can isolate the number x. And how can you eliminate the number 3? The number 3 is operated with x. And which is the operation here? It is multiplication. So, the multiplication operation can be cancelled with the help of an inverse operation. Which is the inverse operation of multiplication? It is division. Okay. So, I am going to divide the number 3 on the LHS. So that it would become 3 into x divided by can be simply written as a by. Okay. And on the denominator, divided by 3 can be written. Which is the operation we done here, the division operation on the LHS. So the same operation has to be carried out on the RHS also. So that it would become 9 divided by 3. Now tell me what happens here. Here the 3 would be eliminated. It would be get cancelled off. By 3 and into 3 would be cancelled off. Then the number remaining would be x. Now the x is isolated. Okay. Here on LHS there is only x. On writing the equal sign, on RHS you can see that 9 and 3 can be divided. How many 3's are there on 9? It would be 3. 3 3's are 9. Okay. So you find the value of x, or you find the solution of x. What is the solution of x? X equals 3. It is the solution of this given equation. Which method is used here? Inverse operation for elimination. Okay. This is done here. I hope you clear about this method. So by the second method, we are going to solve the same equation. Our equation is 3x plus 4 equals 13. But here the method is transposition method. In transposition method, we do not do additional operations, extra operations. But what we do is the operations in the equation itself is transpositioned, or their positions are changed. And it is important to note that while changing the position of an operation, the operation is reversed. If it is addition operation, then while changing the position, it would become subtraction. If it is multiplication, then it would become division. If it is subtraction, then it would become addition, etc. like that. Okay. So we are going to transposition the operations and finding the value of x, or isolating x onto the one side. Okay. So how this can be done? First of all, I am keeping the term 3x onto the LHS. Okay. Then I am putting the equal sign. Then onto the RHS, there is 13 already there on the RHS. Now this plus 4, addition of 4, that I am going to transpose onto the right hand side. So when this addition plus 4 transposed to the right hand side, it would become minus 4. When we are transposing, the operation must be reversed. Okay, so plus 4 would become minus 4. Now on the next step, I can say that 3 and this x is into x. Okay, that would be equal to 13 minus 4. The answer is 9. So after this, you need to eliminate, or you need to remove this 3 also. How can you remove? You can transpose this 3 onto the other side. You can transposition, change the position of this 3 onto the right hand side. But you can see that the 3 is operated as a multiplication. So when that multiplication operation is carried out to the right hand side, it would become division. Okay, so I am isolating x here, then putting the equal sign. Then on the RHS, there is already 9 there. Now the 3 which is multiplied has to be transposed to the other side. Then multiplication would become division. Multiplicating 3, when it is transposed to the other side, it would become dividing 3. Multiplied by 3 would become divided by 3. Okay. The number will not change. Only the operations are reversed. Clear? Multiplication is reversed to division. Okay. Now we can simplify the answer. X equals 9 divided by 3, which is 3 itself. Whatever may be the method we used, the answer would be correct. Same in both the cases. Okay. So I hope you clear about how the solution or solving of a linear equation can be done by using the two different methods. On our exams or on our questions, which is the simplest method that we can use, it would be transposition method. So for the next sessions, we only follow the transposition method unless it is specified. Okay. So let's do some problems related with this transposition method and solving of linear equations on our next class. Some homeworks of simple linear equations could be given for you to solve, and all of you must have to do those works and send to me. Okay, today we wind up our class. We can see on our next class. Bye.